trigonometry. Here we are. Welcome to trig. Oh, I feel like I'm gonna sneeze. Okay, so what is trigonometry? It is the study of the relationship. Okay, the study of the relationship between a triangle's side lengths. Totally gonna run out of room here. Yep. A triangle's side lengths and angle measures. Now, hopefully you remember from geometry, but we're going to do a very fast, very quick review. If you look at the triangle to your left, we have three angles. We've got angle A, angle B, and angle C. And angles are always listed with capital letters. Okay? Angles are always listed with capital letters. Then you'll see that they have their corresponding sides. So little a is across from big A. Little b is across from big B. And little c is across from big C. Side lengths are always used or always written as lowercase letters. And they are always across from their corresponding angle. Okay, all of the stuff that I'm talking about, you should probably write down. The last thing is, let's do green, is theta. Okay, there will always be sometimes theta, it's a Greek letter in the Greek alphabet, sometimes beta, sometimes alpha, but it is your reference angle. Okay, so if I'm using theta, that means that all of the trig functions that I'm about to look at or look for are based off of this angle right here. That's what your reference angle is. So we have three main trig functions. And we're going to use theta as our example. So the first one is sine. Okay, we say the sine of theta, and do not sin. Oh, Lord help me. We're not sinning. Well, you are if you say sin. Which is the sine is the opposite over the hypotenuse. Okay, so our example is that the sine of theta, the opposite is across, and the hypotenuse is always across from the 90-degree angle. So this would be little a over little c. Okay, we've got sine, we have cosine. So the cosine of theta is the adjacent over the hypotenuse. Our example for the cosine of theta, well, the adjacent is what is right next to it. If you're adjacent, you're next to. Okay, and then again, the hypotenuse is across from the 90-degree angle, so we say little b over little c. The last one out of these three main is tangent. So the tangent of theta is the opposite over the hypotenuse. I feel like my writing is terrible. I'm so sorry. So if we look at our example for the tangent of theta, the opposite is across the side that is across from the angle, the reference angle. The adjacent is the side that is right next to the reference angle. So we would say this is A over B. Some of you may have learned these as SOHCAHTOA. Okay, just a fun little acronym for us to remember that the sine is opposite over hypotenuse, the cosine is adjacent over hypotenuse, and the tangent is opposite over adjacent. Now, those are the three main, but there are 6 trig functions we need to be held accountable for. And we have the reciprocal trig functions. Okay, the reciprocal trig functions. Now, the reciprocal of sine is called cosecant. So the cosecant of a given angle is the hypotenuse over the opposite. For our example, the cosecant of theta would be c over a. They are literally the reciprocals. The reciprocal of cosine is secant. Secant of theta is the hypotenuse over the adjacent. So for our example, secant of theta would be c over b. And then the reciprocal for tangent is cotangent, which would be, why did I put that is, I'm a knucklehead. There we go. I think I said adjacent and wrote hypotenuse. So the reciprocal of tangent is cotangent, which is adjacent over opposite. For our example, cotangent of theta would be b over a. So those are the 6 trig functions that you will be held responsible for. Yes, there are the inverses. We'll get to those in a little bit. So let's just start using it. This should be review. If it's not, well, hey, this is exciting. Okay, so find the value of 6 trig functions for angle theta. So theta is our reference angle. Okay, the sine of theta is opposite over hypotenuse. The opposite leg is 5. The hypotenuse is 13 because that's the leg across from the right angle, from the 90 degrees. The cosine of theta is adjacent over hypotenuse. The leg that is adjacent right next to theta is 12, and the hypotenuse is 13. Tangent of theta, opposite over adjacent, so opposite leg is 5 and the adjacent is 12. For the reciprocals, well, the cosecant of theta is the reciprocal of sine, so it's 13/5. The reciprocal for cosine is secant, so the secant of theta is 13/12, and the reciprocal for tangent is cotangent, so the cotangent of theta is 12/5. All 6 trig functions are ratios. Do not ever, please put them into decimal format. Yes, you can reduce them, and you should, but they are to remain in ratios because it's the relationship of the side lengths. We're not putting them into decimal format. Okay, example 2. Find the tangent of A when the cosine of A is 2/3. All right, well, we're dealing with right triangles because this is right triangle trigonometry. So let's draw a right triangle. I'm going to say that this is side A. Does it matter? Or angle A, pardon me. Does it matter? No. I could have put A on the other angle. It just can't be the right angle. So cosine is adjacent over hypotenuse. So the adjacent leg to angle A would be 2. And the hypotenuse across from the 90 degrees would be 3. Well, I need to find the tangent. And tangent is opposite over adjacent. We don't know the opposite leg. So how do we find it? Dun, 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 Pythagorean theorem. The Pythagorean theorem says that you have one leg squared plus another leg squared equal to the hypotenuse squared. This is how we're going to find that opposite leg length. So x squared is equal to, oh no, we're definitely not equal to yet. X squared plus 4 is equal to 9. I'm going to subtract 4, so x squared is equal to 5. Now, when we take the square root of both sides, we would do plus and minus, right? However, we're talking about length, so we only want the positive. So x is the square root of 5. Excellent. Okay, so then the tangent of A is the opposite leg, which is the square root of 5, over the adjacent, which is 2. We've found what they had asked for. Sometimes, yes, you're going to have to draw the triangle. You're going to have to decipher the information they gave you and then see if you can answer the question from there. For example 3, find x if the sine of x is 0.7590, round to the nearest degree. Well, something to note, and you might want to write this down, is that these 6 trig functions are all applied to the angle measure. Sine, cosine, tangent, cosecant, secant, and cotangent are all applied to an angle. They give you the ratio of the sides. Okay? Again, they're all applied only to an angle. They give you the ratio of the side lengths. So if I need to work backwards, I don't have the angle. I do have the side lengths. Enter in your inverse trig functions. So I'm going to say that the inverse sine of 0.7590 will give me the angle. Okay, remember that when we talked about inverses, the -1 exponent means inverse. So regular trig functions are applied to the angle. They give you the ratio of the sides. The inverse trig functions are applied to the side lengths. They give you the angle measure. If you need to pause this video and write that down. Okay, so on your calculators, you'll notice pretty much like halfway through in the middle, you'll see sine, cosine, and tangent. Their second functions are their inverses. So go ahead and put in the inverse of 0.7590 and rounding to the nearest degree, you should get 49 degrees. If you got a different value, you need to go to mode and you need to make sure that you are in degree mode, not rad. Rad stands for radians. Okay, we need to make sure we're in degree mode because we're looking for the nearest degree. Okay, so again, halfway down about in the middle, you'll see sine, cosine, and tangent. Their second functions are the inverses. So you want to hit second sine 0.7590 and you should get approximately 49 degrees. If you have any questions on the calculator piece, don't worry. We'll definitely be doing a lot of it together in class. Write down your questions and ask me when we meet next time. Okay. All right, example 4. Solve each triangle. Round sides to the nearest tenth. Okay, so sides are to the nearest tenth and angles to the nearest degree. Well, in order to solve a triangle has 3 angles and 3 side lengths. So you need to find the missing pieces. For 4A, I'm missing angle A and I'm missing angle B. So let's find angle A first. I do have all 3 sides, so I could use sine, cosine, and tangent. It doesn't matter. I'm going to choose tangent. I'm going to say that the tangent of angle A is opposite over adjacent. The opposite leg is 12. The adjacent leg is 9. And then I'm going to use my inverse tangent of the side ratios to give me the angle. Okay, so I'm going to hit on my calculator second tangent. I'm going to put in 12 divided by 9. And I'm going to find that the measure of angle A is approximately 53 degrees. Now, we could, because we just solved and we know that this is 53 degrees, 3 angles in a triangle add up to 180. So I could take 90 plus 53 and subtract that sum from 180. That will give me angle B. Absolutely. We could also use a trig function. So let's use, just for practice, we'll do the sine of angle B. Okay, so if B is over here, the opposite leg is 9 and the hypotenuse is 15. Again, the hypotenuse is the leg that's across from 90 degrees. So we'll use the inverse sine of the ratio of the sides, which is 9 over 15, to give us the measure of angle B. And then if I were to put this into my calculator, I'm going to hit second sine to find the inverse, 9 divided by 15. And rounding, I get approximately 37 degrees. Okay, that's option number 1. Like I mentioned, option number 2, I could have taken 180 degrees and subtracted 53 plus 90. Okay, so 180 minus 143, and that'll give me 37 as well. You've got 2 options to find that additional angle if you find yourself in a similar situation. Okay, so let's look at B. Remember, when solving a triangle, you have to find all missing side lengths and angle measures. Right away, I have angle X. I've got leg Z. We know, of course, this is a right angle because we're using right triangle trigonometry. Let's find the measure of angle Y. Okay, so I am, for the measure of angle Y, I'm going to take 180 degrees, and I'm going to subtract the sum of 63 plus 90. So we get 180 degrees minus 153 degrees. So the measure of angle Y is going to be, what is that? 27 degrees. I didn't approximate because these were given to me. Okay, 63 degrees was given to me. Some of you may be thinking, well, wait a second. Angle X and angle Y are complementary. They add up to 90 degrees. So can't I just subtract 63 from 90? Absolutely. You are more than welcome to do that. Okay, we need to find the missing side lengths. So I am going to, and please note, you always want to use the given. I am going to find little x. How? Well, I have the measure of angle X. Little x is its opposite. I have the hypotenuse. So I'm going to use, and I'm going to box this real quick. I'm going to use the sine of 63 degrees to give me little x over 23. Okay, multiplying both sides by 23, I'm going to say that x is equal to 23 times the sine of 63. And putting that into my calculator, 23 times the sine of 63. I know my calculator is in degree mode, which is perfect. I'm going to put 20.5 units. Why did I round to the tenths? Because the directions told me to for the side lengths. Excellent. Okay, so we have found that little x is 20.5 units. I now need to find little y. Two options. We could, of course, use trig functions. So I'm going to use the given angle to find the adjacent, and I have the hypotenuse. So the cosine of 63 degrees is going to equal little y over 23. Okay, so again, multiplying, we get little y is equal to 23 times the cosine of 63 degrees. Putting that into our calculator, times cosine of 63, we get that little y is approximately 10.4 units. But let's say we didn't want to use the trig functions. All right, option number 2. This is a right triangle. I could use the Pythagorean theorem. One leg, we'll call that y squared, plus the other leg squared will equal the hypotenuse squared. So if we take 23 squared and subtract 20.5 squared, we get that y squared is equal to 108.75. If we were to take the square root of the answer, just plugging it into my calculator, we get that y is approximately 10.4 units. So you've got two options when you come to that last piece of solving the triangle. Please know that you need to put units because we're dealing with side lengths. And hopefully this was a nice little refresher for you guys. If not, we got a little bit of work to do, but we can do it. All right, I'll see you guys in class.